This video will cover elastic load balancing. Modern high-traffic websites must serve hundreds of thousands, if not millions, of concurrent requests from users or clients, and then return the correct text, images, video, or application data in a fast and reliable manner. To meet these high-volume demands, additional servers are generally required. Elastic load balancing is an AWS service that distributes incoming application or network traffic across multiple targets, such as EC2 instances, containers, IP addresses, and Lambda functions, in a single availability zone or across multiple availability zones. Elastic load balancing scales your load balancer as traffic to your application changes over time. It can automatically scale to most workloads. There are three types of elastic load balancers, such as an application load balancer, which operates at the application level, or layer 7, of the OSI model. It routes traffic to targets based on content of the request. It is ideal for advanced load balancing of HTTP and HTTPS traffic. An application load balancer provides advanced request routing that is targeted at delivery of modern application architectures, including microservices and container-based applications. An application load balancer simplifies and improves the security of your application by ensuring that the latest secure sockets layer and transport security layer, ciphers, and protocols are used at all times. Additionally, a network load balancer operates the network transport level, or layer 4, of the OSI model, routing connections to targets based on IP protocol data. It works well for load balancing both TCP and UDP traffic. A network load balancer is capable of handling millions of requests per second while maintaining ultra-low latencies. A network load balancer is optimized to handle sudden and volatile network traffic patterns. Finally, a classic load balancer provides basic load balancing across multiple EC2 instances, and it operates at both the application level and network transport level. A classic load balancer supports the load balancing of applications that use HTTP, HTTPS, TCP, and SSL protocols. The classic load balancer is an older implementation, and when possible, AWS recommends that you use a dedicated application load balancer or a network load balancer. A load balancer accepts incoming traffic from clients and routes requests to its registered targets in one or more availability zones. You configure your load balancer to accept incoming traffic by specifying one or more listeners. A listener is a process that checks for connection requests. It is configured with a protocol, like HTTP, and a port number, such as port 80. Similarly, it is configured with a protocol and a port number for connections from the load balancers to the targets. You can also configure your load balancer to perform health checks, which are used to monitor the health of the registered targets so that the load balancer only sends requests to the healthy instances. When the load balancer detects an unhealthy target, it stops routing traffic to that target. It then resumes routing traffic to that target when it detects that the target is healthy again. There is a key difference in how the load balancer types are configured. With an application and network load balancer, you register targets in target groups and route traffic to the target groups. With classic load balancers, you register instances with the load balancer. There are many elastic load balancing use cases. Let's consider the main ones. First, you can use elastic load balancing to achieve high availability and better fault tolerance for your applications. Elastic load balancing balances traffic across healthy targets in multiple availability zones. If one or more of your targets is in a single availability zone and unhealthy, elastic load balancing will route target traffic to healthy targets in other availability zones. After the targets return to a healthy state, load balancing will automatically resume traffic to them. Next, there's an enhanced container support for elastic load balancing, so you can use a load balancer to automatically load balance your containerized applications across multiple ports on the same EC2 instance. You can also take advantage of deep integration with Amazon Elastic Container Service, which provides a fully managed container offering. You only need to register a service with a load balancer, and Amazon ECS transparently manages registration and deregistration of the Docker containers. The load balancer automatically detects the port and dynamically reconfigures itself. To learn more about elastic load balancing use cases, visit the AWS website. There are a few ways that you can monitor your load balancers, analyze traffic patterns, and troubleshoot issues with your load balancers and targets. One way is to use Amazon CloudWatch metrics. Elastic Load Balancing publishes data points to Amazon CloudWatch for your load balancers and your targets. CloudWatch enables you to retrieve statistics about those data points as an ordered set of time series data, known as metrics. You can use metrics to verify that your system is performing as expected. For example, you can create a CloudWatch alarm to monitor specified metric and initiate an action, such as sending a notification to an email address. If the metric goes outside of what you consider is acceptable, it can then send that message. You can also use access logs to capture detailed information about the requests that were made to your load balancer and store them as a log file in Amazon S3. You can also use these access logs to analyze traffic patterns and to troubleshoot issues with your targets or backend applications. Finally, you can use AWS CloudTrail to capture detailed information about the calls that were made to the Elastic Load Balancing API and store them as log files in Amazon S3. You can use these CloudTrail logs to determine who made the call, what calls were made, when the call was made, the source IP address of where the call came from, and so on. Thanks for watching. We'll see you in the next video.